Hello, everyone, both in person and online. Thank you for coming to our Sign workshop. I am Jack. I am the CTO of Sign Protocol, also known as a overworked developer. And I have my colleague Jordan here. I'll let him introduce himself.
Yeah, hi, my name is Jordan Bettencourt. I am the prototype development lead at Sign Protocol. So for me, I play with a bunch of new technologies and just see how those things will integrate well with ours. So I'll talk more a little bit later, but I'm going to pass it back to Jack.
Yeah, and the reason why we're here today is because obviously we're giving away money at this hackathon, and you'd like to get that money and maybe learn more about who we are. So for us, we are Sign. If you have been in this space for a while, you might know us as ETHSign. We did like a minor rebranding because now we've expanded past just like the EVM network, so we decided to call ourselves Sign. And our mission is to build a decentralized proving protocol that brings off-chain identity, ownership, and consent on-chain to accelerate tokenization. Okay? So basically, another way to think about it is that we're trying to build an on-chain open data repository that allows anyone to post information in an open manner on-chain, in an open, structured, and indexable manner. We provide an indexing service to our developers. So basically, just on-chain database is a good way to think about it. And also, if you know us, you will know that we had an old product called ETHSign. It's still here. It's basically on-chain DocuSign. We have another product called Token Table, which is on-chain token vesting for investors or airdrop distribution. But for this hackathon, we're focusing on Sign Protocol, which is what I just described, the on-chain database. Okay. So the way that Sign Protocol really works, and we don't have too much time, so I'll be brief with this. And you can find us at our booth, and I can go over all this in much more depth. But basically, the idea is that in order to post some data on Sign Protocol, first you have to create a schema. So a schema basically defines, well, let me put it this way. So the data that you actually post onto our protocol are called attestations. So you can think of them as database entries. But before you add entries in your database, you have to first define a database schema. So that's also what you have to do first here. You have to first define your schema, which basically has a lot of metadata that about the attestations that you're going to make. For example, if they are revocable. For example, do they have like a set expiration date, things like that, or their data format, right? And in like JSON format, so it's human readable. And once you do that, right, you then are able to create attestations under that schema in order to basically actually start writing data onto the blockchain. And not only the blockchain like EVM chains, but we also provide a more cost-effective solution, which is posting data on Arweave. You're able to index everything just as well. We provide an indexing service called SignScan, and basically, it's 100 times cheaper, right? So you can actually post pretty heavy data up there. So this is a diagram, and this is available on our GitHub. I'm so sorry, everyone. This is available on our GitHub examples. Okay, I will actually quit this, and I'll find a place where I can actually zoom in. I'm sorry for the light mode. That's Jordan's fault, not my fault, actually. Also, he scrolls in the wrong direction on his laptop. Oh, I'm sorry. Ooh, almost showed something sketchy there. Okay. So we have three different identities kind of in Sign Protocol. You've got the schema creator, you've got the data consumer. I keep scrolling in the wrong direction and the attester, right? So in the beginning, before any data can be posted, you first have to create the schema, right? So these are the steps. First, you have to create, so there are two ways. On-chain schema just means it's saved on like a chain like EVM or Starknet. And off-chain, it just means like Arweave, right? I'm just using those terms to not confuse people, right? And when you create an on-chain schema, basically you have like this block here. I will zoom out a little bit, okay? So we have the Sign Protocol registry, and then we have the Sign Protocol smart contract. You have different schemas. And as you can see from this graphic, right, the individual attestations actually belong inside the schema, right? And here's this interesting thing that I didn't really talk about. There's something called a hook, external hook contract. So when you're creating a schema, you're able to define a hook contract, which is basically an external smart contract that every time when someone tries to make an attestation, their attestation data will go through the hook contract. And that hook contract will have access to all the context, like the schema ID, attestation content. So they can do like data validation, they can do checking, they can call like other things, you know. So it's just anything that you want. You just have to conform to an interface. But it does have to be defined when you first create the schema, and the schema once created cannot be modified because, like, if you create a schema and people make like 100 attestations on it, and then you change it. Should we invalidate the first 100 attestation? Right, it doesn't make too much sense. Okay, so once we're done creating the schema, and also like the Arweave version, because it's not based on smart contracts, unfortunately there is no schema hook functionality. So next, right, the attester. Okay, so what the attester does is that it will either go through the Sign Protocol smart contract or the Sign Protocol API. So the API is more for the Arweave stuff. Right? If the schema is not on Arweave, then most likely your attestation won't be on Arweave. So you go through our smart contract, and then you basically just call the attest function with an attestation object, which contains a schema ID among other things, right? And if there is a hook defined, then your data will actually pass through the hook. Okay. And then as a data consumer, well, you just like query. Right, through the smart contract or through our API or through SignScan, which is our aggregated singular API. It covers all the chains that we support, so it's like we make it pretty easy for our developers. Okay. So let me give you like quick walkthrough of. So first, let me show you what a schema looks like. So this is one of our users of Sign Protocol called Holonym. So they are a ZK-based KYC provider on Optimism, I believe. So they've been using us, as you can see, pretty regularly, and they've racked up quite a lot of attestations. And this is the schema, okay? So and this website is our SignScan. So it's like EtherScan but for Sign, right? So you have the schema name, schema ID, the full schema ID, which contains like the some more information about like which chain it's on, all that kind of stuff. And you have a description. You have the creation date. You have maximum valid time frame. Now, English is my second language, so I wasn't sure how to properly phrase this. I don't know if I can phrase it better, but that's basically, like, if this is set to 1 hour, then it means all attestations created that are created will expire after 1 hour of its creation maximum. So you can impose some kind of limit on that one. Created by Caleb. Thank you, Caleb. So the network, the data location. Now, the data location can actually be separate. So I'll show you later what that means. Transaction ID, you can go to the Block Explorer if they're revocable. Okay, and also the schema details. This is interesting. So this defines the data format that's in the attestations. Now, you don't have to follow these rules. You can feel free to misuse this one, but the only downside is that one, you'll be confusing people how the hell can I decode your data? Because the point of having a schema is to explain to people how they can interpret your data, right? Instead of them having to go through some kind of tool or your documentation, they can just see it here. It's very, very easy, right? And the second downside is that if your schema data doesn't describe your attestation data correctly, then we won't be able to decode it for you on the website, right? So that's another downside. So now we just clicked into an attestation. And you can see also IDs and created at, expired at, everything else. So this one actually expires in a year. So that's quite interesting, right? Who's the attester, what the schema is. Reference attestation, so you can actually link attestations together. And revoked, no. Now, I don't know why that's all caps. I'll have to fix that bug. Or it should be false. So this is like an overview of SignScan. You can go to the front page and check out some of the other ones it's loading. Some of the different schemas that we have, and a lot of these come from our own events and our other products. So there's that. But in terms of code, I'm so sorry, everyone, for blinding you. But this is an example of a schema hook. So a schema hook really is just it's a smart contract, right? And it just has to conform to this interface. Because in the, I'm sorry, it's tiny. Let me try. Okay, here we go. So in the Sign Protocol smart contract, we actually call the hook. We detect if the address is not 0, then we call the hook, and we call these different functions based on the scenario, right? So these two are receiving attestations. Now you can even charge a fee as the I call it resolver here, but it's really the hook. And also if in the schema it says the attestations are able to be revoked, then you'll receive a hook call when the revocation happens, right? And this is an example of a hook that we wrote, right? So it's like a whitelist manager. Basically, the point of this contract is so that it's to maintain a whitelist where only the whitelisted addresses can attest. But there are many more things that you can access, right? So if you look at the parameters here, you've got a tester, schema ID, attestation ID, and then the sender will always be Sign Protocol. So you can call the Sign Protocol contract based on your schema ID, and then you can pull the entire attestation object as well, right? So and we have all of our interfaces public and nicely documented. Look at that, right? I'm proud because I usually don't document things. Yeah, but that's a really quick overview. It's a little bit rushed, but because we don't have enough time. But again, we'll be at the booths, so we're just here to kind of get you started, and I'll hand it over to Jordan to talk about our front-end SDKs.
Yeah, so this is also, I think, pretty simple to get started. You just need to import at /sp-sdk, like you would see here, into Yarn, into NPM, whatever you may use for your package manager. From there, you have access to all of our other functions that should make a lot of this super easy for you to create, whether it's a schema, a attestation, or even to retrieve all of the data from our indexing service. So for example here, I'm just showing you how to create an index service. And in this case, we are creating one for testnet. I fully expect that all of you will use testnets throughout this hackathon. And it's important that you use this testnet because we do separate our testnet index service from the mainnet index service. So if you create the wrong one and you try to query those specific IDs, you will not receive the data you're expecting. With that said, our client, when you go to create these different schemas or attestations, you'll need to specify the mode. So in this case, on-chain, this will give you access to all the different EVM chains. So in this case, we're using base Sepolia, but this could also be off-chain. And in that case, you'd be looking at using Arweave. Within each of those different classes, you have a bunch of different functions. So to start off, I think I'll just go ahead and discuss the indexing service because it's a bit shorter. You have access to query the schemas. The schema list one here will give you the option to supply an object. You can put in any information that you deem necessary. So this could be the attester. This could be your potentially even a schema ID if you already know that. And there are other different things you can also query these based on. So definitely look at our documentation there for that access. And similarly, when you do queries for attestations, it's the same idea. So with this list function here, is basically you supplying the information that you know and expecting to receive a list back on these attestations. With the one that does not say list, so for query schema, query attestation, that takes in an ID. So pass in the ID that you would know ahead of time, and that will respond back with all the relative or relevant information. So if you are retrieving an attestation, it will also send back the relevant schema information as well. So that can help you with decoding, which we also supply a helper function for, which is decode on-chain data. Within that, you'll supply the schema's data field, which basically defines the different types that you'll have in your attestation. And you'll also supply the hex value that we store for just for saving space on our different contracts. Within the actual Sign Protocol client itself, you will be able to create schemas, get schemas, delegate. So when you potentially want to delegate schema or attestation creation on behalf of a user, you can also do that too. So potentially you might consider, as a backend, you want to create something on someone's behalf and still technically have them be the attester. They would need to sign to essentially approve this information, and then you could potentially pay gas fees for them or something along those lines. So in that case, you would need to sign it. You would pass in that signature along with all the attestation data that you'd have in the create schema or potentially create attestation functions. And the idea there is we don't want somebody to create an attestation on your behalf without you knowing about it. You need to approve that somebody has access to make an attestation for you, because otherwise it's a major security risk. And as I move down here, you can get the attestations and then lastly revoke. So same as when you create schemas or create attestations, you can also do a delegate revocation as well. You would also just pass in that signature into the function and you're good to go. Do note that revoke may revert if the schema does not support it. So in that time, the smart contract will check and make sure that you are able to revoke each of your attestations before actually proceeding with that action. With that said, please join us on Discord, on Telegram, whatever's easiest for you. These are just a couple of links we have. Feel free to also stop by our booth. We can give you more links. You guys can get in contact with us directly if you'd wish. And I believe that's it.
We made it on time. Yeah.
So with that said, we can go ahead and turn this over to questions that you guys may have for us. If there's anything else, yes. Just for the recording, the Arweave testnet, you're asking?
Repeat the question.
Yes. So he's asking, when you're using Arweave, it was you're asking if it's based on an Arweave testnet or if it's on Arweave? Yeah, for the hackathon. Yeah, so for using off-chain on the hackathon, it is actually on Arweave's mainnet. We pay the fees. There is no fee for you. It'll be free for you to access. Arweave is cheap enough that we just sponsor the fees for you. So if you really want like the ultimate cost saving, obviously testnet you can probably find through ETHGlobal. You can find the different faucets, but for Arweave it's paid for.
But there's you don't have the callback if you use that.
Correct. That is the trade-off with Arweave. With Arweave, you will not be able to set up a schema hook. That all the schema hooks are specifically referencing smart contracts on chain, and there is no way for us to call that from our backend to get that information processed.
Sorry, can you explain how the schema hook works?
Yeah, you bet.
Yeah, so the way that the schema hook works, and let me go back to the picture that no one can see. So basically, a schema hook is an external smart contract that's attached to a schema. By attached, I mean that the schema references when you first create the schema. So there will be a field that if you use our UI, it will ask you what's your like schema hook contract address. So it's a contract that you write yourself, right? And it has to conform to. Okay, how do I unclose? Technology. So the hook that you have to write has to conform to this interface. Right, so the contract that you write has to conform to this interface because these are the functions that the Sign Protocol smart contract will be calling, right? And we have an example here. Well, this one didn't. So we have like 3 different schema hook examples actually. Actually two. Sorry. So this is like a more complicated one. But basically, every time you make an attestation. Okay, every time an attestation is made on the schema with a schema hook, the data will first go through the hook, run through the hook logic. Now, the logic could be you can check for who the attester is. You can decode the attestation data to see like if some value is sufficient or whatever, whatever your conditions are. Or maybe you simply want to call another function in a different smart contract to notify them of something. That's all fine, right? But the point is like you have the power to like revert the attestation, the attest call in your hook contract. So it's a way for you to like you can use it as a way for you to like gatekeep your schema or something. Like maybe only people authorized can attest because it's like whitelist. It's like a whitelisted system or something.
Take payments too.
Yeah. I didn't hear what you said.
Just to take payments. Yeah, I mean, the last thing I was just trying to say there is, you can also just take payments. I know we briefly mentioned that earlier, but if you wanted, potentially your use case here for these attestations, maybe you want to charge something to the users making these attestations. If they don't pay enough, you could revert. So some different, criteria there, but it really comes down to whatever you feel the need to do when somebody's trying to either make an attestation, so create one, or potentially revoke it. Those 2 times are when you'd be receiving calls to the schema hook. And do whatever you want with that information. You can revert if you just felt like it, flip a coin. But it just comes down to whatever logic you want to build. All right, thanks guys. That's our time. Please feel free to stop by our booth, ask us any questions you may have. We'll be here throughout the weekend. We're happy to help. Thanks.